Hey everyone. All right, so the second lesson for Unit 1 is going to be about solving one variable equations. So just to kind of start off, we're going to start off with some vocabulary that's really imperative to understand. So the first one we have is called inverse operations. So inverse operations are operations that essentially just undo each other. They're the opposites. So an example here, so first one we have is addition and subtraction, for example. Addition is the opposite of subtraction. Subtraction is the opposite of addition. So we also have multiplication and division. And another one I want to make you aware of is if we square something and if we take the square root of something. So those are also inverses. So we're going to be dealing with the second one or this last one over here a little bit here and there, but just to make you aware of it. So when we're actually solving equations, we're actually going to be using those inverse operations. So another way you can kind of look at it is if you're doing Pemdas backwards. So some people have some funny names for it. I call it just sad meep. I don't know why. It's just what stuck with me. But we're just doing Pemdas backwards. So just a little refresher. So you guys have probably solved a few equations here and there before in middle school. So here we have 2 times x equals 8. So if there's no operation in the middle between those two terms, you assume it's going to be multiplication. So I know I'm doing 2 times x. So in order to solve, I want to do the opposite of multiplication. So the opposite of multiplication is division. So I'm going to divide both sides. So you probably heard what you do to one side, you have to do to the other. So when I divide, 2 over 2, those simplify. They do not cancel, they simplify. Another part of learning here is we have to use the proper terminology. So 8 over 2 is 8 divided by 2, which gives you 4. So your x value here is 4. So looking over here at the next one. So now we have y plus 2 equals negative 7. So remember, our goal here is to get the variable by itself. So anything on the same side as the variable, it has to go. So that means this positive 2 right here, because it's on the same side of the variable, it's got to go to the other side. So you're looking here, so we're adding 2, so the opposite of addition is subtraction. So I'm going to subtract 2 on both sides. So here, the 2 and negative 2 here, they do not cancel. These zero out. So a little thing to note up here, if it's addition and subtraction, these values zero out, they make a 0 pair, whereas multiplication and division, these simplify. So please be aware of the terminology, because if you say cancel out, I will probably start crying. So you're going to have y equals, so we have negative 7 minus 2. So if you have trouble with negatives, think of it in terms of money. A negative is you owe someone money, whereas a positive is that's money in your pocket. So this is saying a negative 7, so you owe someone $7, and a negative 2, you owe someone else $2. So if you owe someone $7 and you owe someone else $2, in total, you owe $9. So y equals negative 9. So if money helps you with positives and negatives, go for it. All right, so now we're going to start bringing in what we did in 1A. So the combining like terms and distributive property. So these are going to also bring in multi-step. So those up there were single step. So this is where inverse operations is going to come into play. So there is a very specific order in which you must solve these equations. So you have to do inverse operations. So you want to start with any addition or subtraction first, then you can move on to division and multiplication. So you want to look in terms of the variable. So I'm solving for W. So here I'm doing 2 times W. So I have multiplication. And then here I have W plus 3. So I have both addition and multiplication. So that tells me I have to do the addition first. I have to get rid of that before I do anything else. So because I have to get rid of the addition, I'm going to subtract 3 on both sides. You've got to do inverse operations. So these zero out. So I have 2W equals 11 minus 3, which gives you 8. So that was our first step. So now that we did our addition, now we can move on to multiplication. So because I'm multiplying here, you want to do the opposite. So the opposite of multiplication is division. So the 2 over 2, those simplify. So I have W equals 8 divided by 2, which is 4. All right, next one here. So this one's a little bit more tricky. So specifically because of this negative here, that's why this one's a little bit more tricky. So what this tells us is there's actually a -1 on the outside of the parentheses, which means we have to distribute. So when I distribute, you're going to have negative G, then -1 times -4. Remember, a negative times a negative gives you a positive. So you'd have negative G plus 4 equals 14. So we're not changing the 14, that stays the same. You're only distributing to what's inside the parentheses. So you can write the -1 in the front if you want. You don't have to write the 1. I would say try to get in the habit of not writing it. But if you need it, it's okay. So that was the first step. So the next step is I need to undo any addition and subtraction first. So I have that +4 that I got to get rid of. So because it's adding, I'm going to subtract. At least I will try to, if my Apple Pencil will work. So negative G equals 14 minus 4, which gives you 10. So here's the thing. You're still not done. This negative out in the front, you still have to get rid of. So just like before, there's a -1 there. So here, what we're doing is we're doing -1 times G. So you actually have to undo that multiplication. So I'm going to divide by a -1. So you'll have G equals -10. All right, so one way to actually check these answers and check the validity is you can actually take these answers and plug them into your equation just to check them, which I will say will come in very handy when you're doing the assessment. Hint, hint. So I'm going to go ahead and check this one. So 2 times 4 plus 3 equals 11. So I'm checking the validity. So I want to see if it's equal. So I'm going to take that W value that I just found, and I'm going to plug it in for the W in the equation. And I want to see if it actually checks out. So 2 times 4 gives you 8 plus 3. Last time I checked, that works. So it works. So same thing over here. So negative parentheses, -10 minus 4 equals, not negative, equals 14. So you have a couple different options here. You could distribute the negative and then combine like terms, or you can combine like terms in the parentheses first and then distribute the negative. So I'm actually going to combine in the parentheses first. So -10 minus 4, that gives you -14. And I still have that negative on the outside. So a negative times a negative gives you a positive. So I have +14 equals +14. So once again, this one works. It checks out. So I highly recommend that you take your solution and you plug it back in just to check and verify your solution. It will come in very handy. I'm just saying, especially on those assessments. Okay, this next one. So we have x over 4 equals 10. So whenever you see something written like this is the same as division. So I am doing x divided by 4. So the opposite of division, multiply. So multiply both sides by 4. So this simplifies. The 4 over 4, they're simplifying. So all you're left with on the left side is x equals 10 times 4, which gives you x equals 40. Okay, so for this next part, I'm actually going to do this one again, but in much greater detail. So if you don't need the detail, feel free to fast forward, or if you need it to make more sense of what just happened, I would highly recommend you watch. So x over 4 equals 10. So I'm actually going to rewrite this. So what I'm going to do is I'm going to move the x out of the numerator and just put it on the side. So I have 1/4 times x equals 10. So what I'm going to do, now here I have 1 divided by 4. Because I'm dividing by 4, I'm going to multiply both sides by 4. Now when I multiply by 4, I'm actually multiplying by 4 over 1. So when you multiply fractions, remember you're multiplying across. So 4 times 1 and 1 times 4. So that would give you 4 over 4x equals 10 times 4 over 1. This is also over 1. So 10 times 4 gives you 40. Now, 4 over 4, that simplifies to 1. So I just have x equals 40 over 1, which is 40. So the left-hand side is the much more condensed version. The right-hand side is the much more elaborate version. I would just expect what I have written on the left side for work. I'm not going to expect what's on the right side. The right side is just for more elaboration if you need it. All right, so the fourth one over here. So once again, we have to undo any addition and subtraction first. So because of this -3 here, that's going to be my first thing I got to do. So remember, you're doing the opposite. So instead of subtraction, you're going to add 3. So I haven't touched that 2/7 x yet, so I'm going to leave it. So 2/7 x equals 1 plus 3, which gives you 4. So the -3 and +3, they zero out. So for this next step, you can do this in 1 or 2 steps. It's really up to you. Whether you're in honors or on level, I don't really care. It's really up to you on how you want to do this next part. So I'm going to do this in 2 steps. I believe it's actually easier if I do it in 2 steps. So I'm trying to get rid of this 2/7 here. So I'm doing times 2 and divided by 7. So you got to get rid of both of those values. So first thing I want to do is I want to get rid of that 7. So because I'm dividing by 7, I'm going to multiply by 7. So when I do that, the 7's here, they simplify. So what I'm left with is I have 2x, so the 2 from the numerator and the x from the side, equals 4 times 7, which gives you 28. Now I'm doing 2 times x, and I need to divide. So I'm going to divide both sides by 2. So you're going to have x equals 14. Okay, so once again, I'm actually going to do this problem again and just show you how to do it in 1 step if you'd like. It's really all the same. Okay, so add 3 first, same thing here. So those zero out, so you have 2/7 x equals 4. All right, so what I'm going to do here to do it in 1 step, I'm going to multiply by what we call the reciprocal. So the reciprocal is if you literally just take the fraction and flip it. So instead of 2/7, I'm going to multiply by 7 over 2. So when you're multiplying, the 7 over 7 here, they would simplify. The 2 over 2 here, they would simplify. So all you have left on the left side is you just have x. Now on the right side, you're going to have 4 over 1 and 7 over 2. So you're going to multiply across, so 4 times 7, which gives you 28, and 1 times 2, which gives you 2. divide, and you get 14. So either way, you get the same thing. It doesn't really matter. If you're first starting out and you're still not comfortable with solving equations, I would honestly recommend doing it in 2 steps. So what I have on the left, if you're really trying to do this in as fewer steps as possible, I would highly recommend doing what's on the right side. So if you want, whenever you're doing these on your own, this part right here was really just more of an elaboration. So you wouldn't even have to necessarily include all that. So you could just go from here to there. All right, so this is just single multi-step equations. So now the variable may end up being on both sides of your equation. So here's the thing. There's a couple things I stress on these. You want to remove the variable from both, or from one side. You want to get the variables to one side. So always, 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 always start with the variables. Because of special cases, that's why. So we're gonna get to special cases in a little bit. But whenever you're moving and adjusting, always start with the variables. All right, so looking at this first one, when I say start with the variables, notice how we have 2x on the left side and negative x on the right side. So we have the variables in 2 different distinct places. So here's the thing, how do you know which one to move and where? Well, always move the smallest variable. I say move the smallest so you can try to avoid negatives at all possible, because I know you guys try to avoid negatives like the plague. So if I have 2x here and I have negative 1x here, well, the smaller one is negative x. So that tells me that's the one that I'm going to move. So what I'm going to do is I'm going to add the x to both sides. So here's the thing, whenever you're adding variables, you have to make sure they're like terms. For example, you can't add 5 and x. They're not like terms. They wouldn't combine. However, 2x and x can combine. So that's where I'm going to add it. So 2x plus x. So think of it this way. I have 2 x's over here, and I have an x over here. Altogether, you have 3. So you can put a 1 in the front if you need to. So that'd be 3x plus 5 equals positive 2. So the x's here, they zeroed out. So that was the first step. So now that I got all the variables on one side, now it's just like the equations that we did above. So undo any addition and subtraction first. So subtract 5. So these will zero out. So I have 3x equals 2 minus 5. So you have $2, you owe someone 5. So if you give them what you owe, you still owe them $3. All right, so the next step here, I have 3 times x, so I need to do the opposite of multiply. So I'm going to divide. So 3 over 3 simplifies. So I'm going to have x equals negative 3 over positive 3 gives you negative 1. So it just adds another step or two when they're on both sides. All right, so this next one. So now we're throwing in the distributive property. So I'm going to distribute. So I have 3x plus 3 times 1, which is 3. Be very careful here. I see a lot of people mess this up. They forget to distribute to the second term. So please be very careful. Equals x minus 1. All right, so now look for your smallest variable. Remember, start with the variables and move the smallest. So between 3x and 1x, well, 1x is your smallest variable. So I'm going to move that one. So here's the thing. You have an x here. How do you know if you add or subtract it? Well, there's no sign in the front, so you assume it's positive. So what I'm going to do is I'm going to subtract it. So you have 3x minus x, which gives you 2x plus 3. The x's here, they zero out. Negative 1. For the next step, got to get rid of that plus 3. So I'm going to subtract 3. So I have 2x equals -1 minus 3, which gives you -4. 3, 0 out. So last but not least, we have 2 times x, undo multiplication by dividing. So I have x equals -2. All right, so now we have the application right here. All right, so given the perimeter of a rectangle is 36 inches, set up an equation and find the value of x. Use the value of x to find the area. So here's the thing. This is going to take a lot of back and forth, kind of. So they gave us the perimeter. So if you recall, the perimeter of a rectangle is 2 times the length plus 2 times the width. So I'm going to say this 12 right here. I'm going to say that's my length. I'm going to say 2x is my width. So they told me the perimeter. So they told me it was 36. So I'm going to plug in. So if I know the perimeter is 36, so I'm going to have 36 equals 2 times my length, which I said was 12, plus 2 times my width, which is 2x. Now I just want to solve this equation for x. So I have 36 equals 2 times 12, which gives you 24, plus 2 times 2x, which gives you 4x. So you're doing 2 times 2. Now you're solving this equation for x. So I'm going to subtract 24. So when you subtract, you get 12 equals 4x. 24 is 0 out. Now you want to divide both sides by 4. So you get 3 equals x. So this is just a little notation thing. You guys see how 3 is on the left side and x is on the right side? It's just a notation thing in math. You always want to write the variable on the left side. So if you write the variable on the right side, like you do up here, it's like riding a bike with square tires. It just, no, just don't do it. All right, so we found the x value. However, that's not what we're looking for. We want to find the area. So what I'm going to do is I'm going to plug in that x value. So 2 times 3. So I know this is actually 6. Now I want to find the area. So I know the area is equal to length times width. I know the length is 12. And as we just saw over here, after I plugged in the x value, we know our width is 6. So multiply them together. So you get 72 square inches. Please don't forget the units. The units are just as important as the actual answer itself. Coming from someone who used to teach geometry, I'm just saying. Go ahead and get in the habit of writing the units. All right, so that's it for that one. All right, so now we're looking at the special cases. So we could have 2 different types of special cases. One in which the answer would be all real numbers, or in which the answer would be what we call no solution. So we're gonna look to see what that looks like mathematically. All right, so what I'm gonna do here is, just like before, start with moving the variables, but you wanna move the smallest one. So if you look here, we have 1x and 1x. Well, they're the same thing, so how do you know which one to move? Well, trick question. When you subtract x on both sides, they both 0 out. So you have 1 equals 4. Last time I checked, those are not equal. So what that means is this is a false statement. And because it is false, that means this is no solution. So you're not going to have x equals anything or whatever. It's just going to be false, no solution. Oh my gosh, that's crooked. It's going to bother me. Everything's fine. All right, next one. So once again, we're bringing back the distributive property. All right, distribute. So 3 times x and 3 times 2. So you're going to get 3x plus 6 equals, that's not an x, 3x plus 6. So what do you notice? They're the same on both sides. So whenever they're the same on both sides, still got to get rid of the variables. So you're going to have 6 equals 6. The x's 0 out. So in this case, 6 is actually equal to 6. So this is true. And what you could say here, you could say all real numbers, or because I'm a math person and I'm lazy, you could also write what we call IMS. So IMS just means infinitely many solutions. It's all the same. So on an exam or an assessment or whatever, if it ever is all real numbers, you could see IMS, you could see infinitely many solutions, you could see all real numbers, or you could even see, so all real numbers, or you could even see the mathematical sign for all real numbers. So the mathematical sign for all real numbers, it looks like a capital R, but with an extra line through it. So literally for those, there's so many different ways that you could show it, but true, IMS. That's what we're going to be looking for on the homework if you do come across one like this. But any of these other answers like this would also be acceptable. Okie dokie. So looking at this third one, it's a little bit more meticulous. All right, so first things first, distribute. So I'm going to leave the left side the same, so 3x minus 12. So when you are multiplying by a 1/2, that's the same as dividing by 2. So 6 divided by 2 gives you 3x, and then 2 divided by 2 gives you 1. All right, now you got to get rid of variables. So subtract 3x on both sides. So you have negative 12 equals positive 1. Last time I checked, that's not right. So this would be no solution. All right, last but not least, this one throws a lot of people off. You have x equals x. Every single time I teach this problem, everyone's just like, what the heck do I even do? All right, well, here's the thing. You have 1x equals 1x. Subtract x on both sides. So if you have x minus x, think of it this way. What's 5 minus 5? 0. So you're going to have 0 equals 0. Kind of looks like a face. It's fine. So because we have 0 equals 0, 0 does equal 0. So that means this is true. And this is IMS. So actually the simplest of them all actually turns out to be one of the most challenging of them all. Okie dokie. Next thing. So now we're looking at algebraic proportions. So just kind of a recap, we're going to solve just a regular proportion. So just like before, to solve a proportion, you want to cross multiply and divide. So those cross values that you're multiplying, that's actually called a cross product. So I'm going to take what's in pink or purple or whatever that is. I'm actually colorblind, I don't know. So I'm going to have 2x equals, and on the other side, perfectionist and I can't. All right. Then on the other side, we have 4 times 3, which gives you 12. I know they're not the same, but it's fine. Close enough. So we have 2x equals 12. So now I did the multiplying, now I want to divide. So divide by 2. So x equals 6. So we're going to do the same idea, but we're going to kind of kick it up a notch. So I'm going to go through the first couple a little bit slower, and then the rest of them I'll go kind of quick. All right, so here's the thing. You now see an algebraic expression up here in the top left. So anytime you see an algebraic expression, this very first part in the steps is so crucial. You have to put parentheses around any value that is more than one term. So if it's x plus something or x minus something or 2x plus 4, like you have to put parentheses around it. So because this up here is more than one term, I have to put parentheses around it first. Then you can do your cross products. So now I'm going to cross multiply. Feel free to get creative with your colors. So I'm going to multiply 3 times x plus 3. And on the other side, I'm going to have 6 times 5. So here's where the parentheses are crucial. The parentheses are what tell you here that you have to distribute. Because if you didn't write those parentheses, you wouldn't distribute and the value would just, everything would just be messed up. So now you can distribute. So 3 times x gives you 3x. 3 times 3 gives you 9. And then 6 times 5 gives you 30. So now it's just like the equations that we solved earlier. So I'm going to subtract 9. So I have 3x equals 21. The 9's 0 out. Now that's not a 3. I'm going to divide by 3. So x equals 7. And once again, just like before, you can plug this in and actually check the validity. So I'll just do it for this first one so you can see. So if I plug in 7 for my x value, so I have 7 plus 3 over 6 equals 5 over 3. So if I do 7 plus 3, you get 10. 10 over 6 equals 5 over 3. So the fraction over here on the left side can actually simplify if you divide everything by 2. So 10 divided by 2 gives you 5. 6 divided by 2 gives you 3. And 5 over 3 equals 5 over 3. That is a true statement, so it works. Now, if you get, say, 7 over 3 equals 5 over 3, that is false, which means you would have to go back and check something. You might have messed up your distribution. You may have missed a negative somewhere. It happens. Okay, so just be aware. What am I doing? There we go. Okay, number 2. So first thing, parentheses, because we have more than one term. Now I'm going to do my cross product. Ew, no. Better. Okay, so 2 parentheses, 3n plus 6 equals 9 times 8. Distribute. So 2 times 3n, which gives you 6n, plus 2 times 6, which gives you 12, and 9 times 8, which gives you 72. All right, solve the equation. So I'm going to subtract 12. So I have 6n equals 60. Divide by 6. So you're going to have n equals 10. That's not a 10. That's a 10. Boom. And once again, you can plug in the answer you get and you can check the validity. I don't know why I gave you guys so much room for this. Everything's fine. All right. So now we have 7 over 16 equals k plus 1 over 4. I would actually say pause here, try this one on your own. That's a highlighter. There we go. All right, cross product. Pink, purple, fuchsia, whatever that is. Gross. All right, anyways. So 16 parentheses k plus 1 equals 7 times 4. So here's another thing that I see happen. It actually doesn't matter what side you put the values on. So if you get it the other way around, that's totally fine. You're going to get the same thing either way, I hope. As long as you do your math right. We all know math is a struggle. All right, so I'm going to distribute. So 7 times 4 is going to give me 28. 16 times k gives you 16k, plus 16 times 1, which gives you 16. All right, I'm going to subtract 16. So you're going to get 12 equals 16x. Why did I write x? That should be a k. Uno momento, por favor. There we go. Okay. My k's look weird. That's fine. So now I'm going to divide by 16 because that's the one with k. Because remember, we're getting k by itself. All right, now here's the thing. 12 is not divisible by 16. However, you can simplify it. So I'm going to have 12 over 16 equals k. Don't be that person. Flip it. All right, now I'm going to simplify. So when you simplify, you want to find the greatest common factor. So between 12 and 16, so just in case you want a refresher on greatest common factor, your GCF. So between 12 and 16, that doesn't need a colon. There we go. Your GCF, well, let's find out. So for 12, your factors are 1, 2, 3, 4, 6, and 12. For 16, you have 1, 2, 4, math is hard, 8, 16. So the greatest common factor that they have is 4. So I'm going to divide both values by 4. So 12 divided by 4 gives you 3 over 4. So what this means, so the double arrow here, that means implies. So k equals 3/4. So once again, just in case, I will be using a lot of math notation and a lot of math symbols. So the arrow means implies. Okay, so just as mentioned before, this is extra. You're not going to be required to write it out. You could literally go from this step to this step if you're confident with it. So I'm not going to make you write everything out like that. Okay, so I would say pause here and try those last 3 on your own. I'm going to go through these kind of fast. All right. So first things first, parentheses. So cross multiply. Okay, so you're going to have -2, parentheses, w minus 2 equals 8w. So I'm going to distribute. So you're going to have -2w plus 4 equals 8w. Now, here we have the variable on both sides. So remember, move the smallest variable. So between -2 and +8, Which one's the smallest? -2. So because it's negative, remember we're doing inverse operations. So you're going to add it. Think of it like a counterbalance. What you do to one side, you have to do to the other. I'm sure your math teachers in the past have told you that countless times. Okay, so here these will zero out. So I have 4 equals 10W. I'm going to divide by 10. So once again, these aren't divisible, but that's okay. So I'm going to skip a couple steps. So I'm going to go to 4 over 10. Simplify, and you get 2 over 5. So just because your answer is a fraction, it doesn't mean it's wrong. You're actually going to be seeing a lot more answers as fractions. So speaking of fractions, one thing I forgot to mention, leave your answers as fractions. Decimals essentially are dead to us. We don't use that many decimals unless we're dealing with like money, which we will get to in like application problems, but that's not going to happen too often. So fractions are going to be the way to go. All right, next one. So we have 6 over c plus 4 equals 42 over 77. So here's the thing. If you're someone like me who looks at this right side and you just want to scream and pull your hair out because big numbers, same. So if you notice, between 42 and 77, those actually have a GCF. So you can actually simplify this fraction before you write it or before you start solving. So your GCF here is 7. So if I divide both and simplify that fraction before I even do anything, you're going to make your question much easier. So if you divide 42 over 7, you're going to get 6. And if you divide 77 by 7, you get 11. So I'm sure this looks a lot better than that. Or if you want to deal with the big numbers, you can. You don't have to do this if you don't want to. This is just a little thing that will help you out if you don't want to deal with big numbers. So first thing, parentheses. So I'm going to cross multiply. So I have 6 times c plus 4 equals 6 times 11. So I'm going to distribute. So 6c plus 24 equals 66. Subtract 24 on both sides. So you're going to have 6c equals 42. 24 is 0 out. Divided by 6, that's not a 6. So you're going to get c equals 7. Boom. All right, last but not least. So now you're going to notice that you actually have the algebraic expression in more than one place. So you actually have to put it around 2 sets. So it's still the same thing. So little disclaimer, we will actually get to problems like this and around unit 8 or 9 when we're dealing with quadratics, and you're going to have nothing but algebraic expressions everywhere. It's going to look like a nightmare, but it's not as bad as it looks. All right, so anyways, cross multiply. So I'm going to do 4 times j minus 3 equals 6, parentheses, j minus 5. So distribute in both places. So you're going to have 4j minus 12 equals 6j minus 30. Okay, so once again, move the smallest variable first. So minus 4j, that's not a j. Okay, so the 4j's, they zero out. So you have negative 12 equals 2j minus 30. Now I'm trying to get j by itself. So I need to get rid of this negative 30. So I'm going to add it on both sides. So negative 12 plus 30 gives you a positive 18 equals 2j. So divide by 2. So you're going to get j equals 9. Boom. Hopefully you didn't cry too much. Everything's fine.